Hi, this is a session on Mathematics, Chapter 1 on real numbers for grade 10, examples 7 and 8 of section 1.3 Fundamental Theorem of Arithmetic. Example 7. It says find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. We have to remember that if a and b are two positive integers, then HCF of a and b multiplied by the LCM of a and b will be equal to the product of a and b. That is, for given two numbers, their HCF multiplied by their LCM is equal to their product. So now let's see, we are given two numbers 96 and 404. So to make our life easier, let's first take 96 and create some factors of it. In our case, it is 32 multiplied by 3. And now let's further decompose them to get the prime factors of 96. So we decompose it further and we get 2 raised to power 5 and 3. These are prime numbers and this is the prime factorization of 96. Similarly, 404, we decomposed it into 101 multiplied by 4. But we decompose it further into the prime factorization of 404. We get 2 raised to power 2 and 1 raised to 101. Hence the HCF of 96 and 404 will be the 2 raised to power 2, which is 4, because HCF is the smallest power of every common prime factor, and the common prime factor between this and this is only 2. And we take the smallest power, which is 2 raised to power 2, that is HCF of these two numbers, that is 96 and 404, is 4. Now we also know that LCM multiplied by HCF is equal to the product of two numbers. Hence LCM of 96 and 404 will be product of the two numbers divided by the HCF, which is equal to 96 multiplied by 404 divided by 4, which is 96, which is 9696. This is our answer. Let's take example number 8 now. We have to find the HCF and LCM of 6, 72, 120 using the prime factorization method. And let's recall the definitions of HCF and LCM. HCF is the product of the smallest power of each common prime factor in the numbers, and the LCM is the product of the greatest power of each prime factor involved in the numbers. So now let's carry out the prime factorization of 6, which is equal to 2 raised to power 1 multiplied by 3 raised to power 1. 72 can be factorized into its primes by 2 raised to power 3 multiplied by 3 raised to power 2. And then 120 will go into 2 raised to power 3, 3 raised to power 1 and 5 raised to power 1. So the HCF of these three numbers here will be 2 raised to power 1 multiplied by 3 raised to power 1, which is equal to 6. Similarly, LCM of the three numbers will be 2 raised to power 3, 3 raised to power 2, 5 raised to power 1, which is equal to 360, because as per the definition, if you see, we have to take the highest powers of the prime factors 2, 3 and 5 in this case, because the prime factors are 5, 3, 2, 5, 3 and 2, 3 and 2. So all the prime factors involved are 2, 3 and 5, and we take their highest powers to get the LCM. So we have found the LCM to be 360, HCF to be 6. So this completes our answer to this question number 8. But you see, we have talked about, in this session itself, we have talked about the HCF of two numbers multiplied by the LCM of two numbers is equal to product of the two numbers. But this thing does not apply to the three numbers situation. So if there are three numbers A, B and C, then the HCF of the three numbers multiplied by their LCM, that is LCM of A, B and C, will not be equal to the multiplication of A, B and C, that is product of A, B and C. And here we can check this in our example, because we are given three numbers 6, 72 and 120. If we multiply 6, 72 and 120, we get 51,840, and if we multiply the HCF and LCM of these three numbers, we get 2,160. Both are not equal to each other, and hence we can say that for the three numbers, their LCM multiplied by their HCF is not equal to their product. So for the three numbers, we can say that.